All right, I think it's fair to say that this is where the fun really starts in engineering mechanics because today we will talk about rigid bodies in equilibrium. And of course, you know a lot already about equilibrium, but the reason this is exciting for me as your teacher is because one of the first thing we need to talk about and we need to calculate is called support reactions. And those support reactions are often not really explained from the ground up. So, for example, while I had a fantastic mechanics teacher back in my days, I was not really systematically taught how to interpret these support reactions and how I connect the physical world to the world on my piece of paper. So I had to kind of pick that up on the way. And yet I was asked to really make sense out of all the problems that were given to me. So today it is therefore my goal to really introduce support reactions to you and really do that from the ground up. I find that very important because it makes no sense to calculate something if you have no physical interpretation of that. At least in the engineering world, it doesn't make sense. And you will learn that we need to use rotational equilibrium, which you're already familiar with, to actually calculate these support reaction. And this is my goal to really explain to you why the rotational equilibrium applies to these kind of physical systems. Ultimately, of course, our goal for the next 3 lectures and also for your upcoming homework is to really determine the support reactions. And we want to understand today how we deal with concentrated loads. I will define that, of course, for you what that is. And then in future lectures, we will talk about things like distributed forces and other types of load cases. But for now, let's just talk about a general introduction to support reactions. And because I'm not able to meet you in the classroom with my props, I now went around town and took some pictures for you. For example, here of a railroad bridge. So in part A, you see the railroad bridge, and then you can see the red box and the blue box, which zoom in on the actual support reactions, which I magnified for you here. And although it's kind of hidden here, this picture still shows a slight difference between the left support and the right support. And the reason I actually picked this picture, although you cannot fully see this support, is because we can beautifully see this type of support. And I first want to talk about this kind here. You can see that on the concrete, which builds the foundation, if you will, for this type of bridge, there's a steel plate. And then on top of that steel plate, you have something that can actually rotate or move because there is effectively a hinge here, and we'll talk more about hinges later, but you see there's a bolt here, so this entire contraption on the bottom can actually move about this point, and this part is also not connected to the bottom steel plate here. Now, sadly, we cannot see this behind the brick wall here, it's kind of hidden, but you will see in other pictures that this part here is actually not allowed to sit freely on this and is actually bolted down. And when that is the case, we call that a simply supported bridge. And I will explain to you later on what simply supported means. But for now, please understand that here on this part, you actually have a friction plane, whereas here you are completely bolted down to the ground. Let's take a look at the next picture. So here we see actually a parking garage, and a parking garage now consists kind of like a Lego system of many parts that are stuck together. And for example, here you can see that there is a pedestal, which is magnified right here, and there sits a concrete beam on top of it. And notice, please, and this is why I highlighted this, notice this little black portion here. That's actually a neoprene pad, which allows the concrete to sit and move in certain ways. And next time you go into a parking garage, pay attention. You can actually see this over and over again. And just for example, I pulled out another picture here, and it's not that easy to see, but the trained eye can find these neoprene pads, and they also guarantee that these elements are actually simply supported. And that will become more clear as we move through the lecture and we see some other pictures. But for now, let's just understand that we as engineers need to develop a solid interpretation of these different support systems, and we need to be able to put them on paper so that we can calculate our numbers based on the real physical world and the real interpretation of these systems. And let's move on to the next page and look at some more pictures about that. So here we have another set of images that can help us to study and learn more about support reactions. Let's zoom in and take a look one by one. So here first you can see a stadium or multi-story building, if you will, in which we have staircases that connect the one floor to the one above, and therefore they need to be supported. These staircases were pre-built and pre-made, and they were just delivered to the construction site and then pretty much put in place. And because they were put in place, they need to be supported by these pedestals once again. You have one on each side. And what you cannot easily see in these images is that there's also a neoprene pad or something else underneath here, because engineers would never allow that the concrete just sits on top of the concrete. There has to be a friction barrier or something that actually allows friction to easily be overcome, or motion to overcome. And we talk more about this when we talk about the degrees of freedom. So engineers want to make sure that if, for example, this part of the structure is exposed to heat and it extends or changes its shape or its dimension, that it still does not affect this part of the structure negatively. So this portion has to be somewhat decoupled from this portion, and the way engineers deal with that is with, for example, neoprene pads that then create a certain support reaction or a certain type of support reaction. All right, let's move on to our next image here, or set of images, for which we can see a ongoing construction site. And the reason I picked this picture is because you can see a beam here on the top. This is similar to the bridge, conceptually speaking at least, that we saw initially. But in this case, we have a very specific type of connection here, and that is magnified right here in the blue. You may be able to see that it's actually welded together. So there's definitely nothing allowed to move between this portion of the structure and this portion of the structure. And this can be executed in other ways as well. So for example, here on the top, if I zoom into that part, you can see a connection. This one was executed through bolts, but it's the same concept. This part of the structure and this part of the structure are rigidly connected to each other, and we actually call that fixed. So that is a very important word to understand. So here we talk about a fixed support or a fixed connection, depends on how you look at it. And here's just another one which sits down here. And I think through this image, you get the picture and you get the concept. Let's take a look at one other famous structure here on campus. And this one here actually also has a connection up here, but in this case, we can only guess because it's behind the building cladding. However, you can see a beam here that is supported, and you can actually see something that is supported here as well. And it also helps to support the roof from here to here. So it's an entire structural system, but that structural system definitely has a connection and a support reaction up here for this roof. And my best guess here, I cannot see inside, but my best guess is that it's also a fixed connection, but we really would have to go and dig into it to really see what's going on. However, you have now seen actually all three types of supports that we will deal with in the future. And the ones that I'm talking about here for this class are called rollers, pins, and fixed supports. So these are the three types of supports that we will deal with in this class, and you kind of have seen them already. Of course, I didn't tell you that because our goal here today is to actually idealize them. But in a general sense, this support here could be probably represented by a roller or a pin. In reality, it's a roller, but sometimes engineers use it as a pin. This one here would also be a roller or a pin. This one here would, without a question, be a fixed support, and so would be this one. Actually, all of them that are highlighted here are fixed supports, and that makes the structure very rigid, which is why I believe that this one here must be also a fixed support because of this overhang that you have here, and that needs to be supported at these two columns. But you have now seen these rollers, pins, and fixed supports as they are be seen in the real world and where they are located. So before we really define what these are and how do we differentiate them, we can look at a general concept and think about how the forces actually do apply at these support reactions. So for example, if you think of this beam here, how does the force come to these supports and how much force do they have to carry? And we will do that with an introductory example on the next page.